It is exactly 3 in the morning in the freezing, rain-soaked hardwood forests of the Missouri Ozarks. You have been awake for 72 continuous hours, operating on a severe caloric deficit, and your quadriceps are actively cramping from carrying an 80-pound rucksack filled with military explosives. You are kneeling in the mud next to a massive steel I-beam, and you have exactly 3 minutes to calculate the precise mathematical quantity of composition C4 required to completely sever the structural support. If you're new here, hit that subscribe button right now and ring the bell. We cover the stories the history books skip. You don't want to miss what's coming next. I served nearly 20 years in the special operations community. I am not going to name names or list specific operations. A lot of that is in the past and some of it stays there. I came back with this body, some titanium hardware in my spine, and a military disability rating. Now this channel is my job. I share the reality of what it takes to survive in the worst conditions on Earth. I share what I know. You watch. That is the exchange. Today we are stripping away the cinematic illusions of massive, uncoordinated explosions to examine the brutal, mathematically unforgiving reality of the United States Army Sapper Leader course. The civilian public envisions combat engineering as simply digging trenches or haphazardly blowing up obsolete buildings. The Department of Defense views the Sapper as a highly specialized human ballistics computer capable of executing complex geometric equations, while their biological systems are experiencing catastrophic failure. Operating out of Fort Leonard Wood, Missouri, the 28-day Sapper Leader course is designed to physically destroy a candidate's body while simultaneously demanding absolute perfection in demolition mathematics. The course evaluates a soldier's ability to facilitate the mobility of friendly forces and completely deny mobility to the enemy. This means clearing minefields under hostile fire, breaching heavily fortified concrete bunkers, and systematically destroying critical bridge infrastructure to halt advancing armored divisions. The financial economics behind combat engineering are incredibly severe. When a Sapper platoon is tasked with destroying a bridge, they are handling tens of thousands of dollars in high explosives, detonating cord, and blasting caps. But the true cost of a Sapper's mistake is measured in strategic failure. If a Sapper miscalculates the required explosive yield, the bridge does not fall. A failed demolition means an entire enemy armored column can cross the river, completely flanking friendly forces and altering the trajectory of a massive geopolitical conflict. The Army cannot afford engineers who guess. They require engineers who calculate. To ensure candidates can perform these calculations under extreme duress, the course utilizes sleep deprivation as a primary biological weapon. The human prefrontal cortex is the region of the brain responsible for complex logic, mathematical reasoning, and working memory. Military physiological research dictates that after 48 hours of continuous wakefulness, the prefrontal cortex begins to systematically shut down. Blood flow to the brain decreases and candidates begin to experience severe cognitive fragmentation. They forget simple instructions, they stare blankly at their maps, and their ability to execute long division completely evaporates. It is exactly in this state of profound neurological impairment that the Sapper instructors force the candidates to calculate the explosive equation. Combat demolition is not a matter of simply strapping blocks of C4 to a target. Every single material requires a distinct mathematical formula to determine the precise pounds of TNT required to destroy it. If a candidate is tasked with cutting a solid steel beam, they cannot rely on intuition. They must measure the cross-sectional area of the steel web and the flanges in square inches. They must then apply the specific steel cutting formula. The underlying physics of cutting structural steel relies on the equation P equals \frac 38 a dollar, where the variable P dollar represents the required pounds of TNT, and the variable a dollar represents the exact cross-sectional area of the steel. If the candidate is exhausted and misplaces a decimal point while calculating the area, the entire mission fails. But the mathematics do not end with the baseline formula. The Army rarely utilizes raw TNT for specialized demolitions. Sappers primarily utilize M112 demolition blocks, which consist of 1.25 pounds of composition C4. C4 is significantly more powerful than TNT. Therefore, the candidate must divide their initial TNT calculation by the relative effectiveness factor of C4, which is mathematically established as 1.34. The final operational equation becomes PC4 equals backslash frac PTNT1, $34. The candidate must execute this division by hand in the dark using a red lens flashlight while freezing rain destroys their notepad. Once they calculate the precise fractional weight of the required explosive, they must physically mold the C4. C4 is a pliable plastic explosive, but in the freezing temperatures of a Missouri winter it becomes rock hard. The exhausted candidates must place the blocks inside their uniforms, using their own rapidly depleting body heat to soften the chemical compound until it can be physically pressed into the exact geometric shape of the steel beam. If the explosive does not make perfect flush contact with the target, the kinetic shockwave will completely dissipate into the air and the steel will not break. The equations change aggressively depending on the operational environment. If the sapper is ordered to destroy a massive oak tree to create an immediate roadblock, they must utilize the timber cutting formula. For an internal charge placed inside a drilled hole, the formula is P equals backslash frac D to $250, where D is the diameter of the tree in inches. If they do not have time to drill and must place an external charge, they use the untamped formula of P equals backslash frac D to $40. The candidate must actively measure the tree, square the diameter, and divide by the correct constant while holding security against simulated enemy patrols. When breaching a heavily reinforced concrete bunker, the variables become exponentially more complex. The candidate must calculate the breaching radius, factor in the specific material strength of the concrete, and determine the tamping factor of the explosive placement using the formula PR3KC. The instructor stands silently nearby, heavily evaluating the squad leader's ability to command a team of starving soldiers to rapidly construct these complex charges before the simulated enemy assault arrives. The physical penalty for this academic phase is relentless. Demolition equipment is incredibly dense and heavy. A single wooden crate of C4 weighs over 60 pounds. A spool of heavy-duty detonating cord adds another massive logistical burden. Sappers do not drive this equipment to the target, they carry it on their backs. The candidates navigate the steep, unforgiving ravines of the Ozark Mountains, carrying rucksacks that frequently exceed 80 pounds. The kinetic impact of carrying high explosives over uneven terrain aggressively destroys the cartilage in the knees and the lower spine. The friction of the heavy canvas straps cuts deeply into the shoulders, causing severe nerve impingement. When the candidates finally arrive at the objective after a 12-mile tactical foot march, their bodies are experiencing massive lactic acid buildup. Their fingers are severely cramped and numb, yet they must immediately execute the highly delicate task of crimping a blasting cap onto a time fuse. Crimping a blasting cap is the most dangerous mechanical procedure in the entire Sapper pipeline. The blasting cap contains a highly sensitive primary explosive designed to initiate the secondary C4 charge. The candidate must insert the time fuse into the open end of the small aluminum tube and use specialized crimping pliers to secure it. If an exhausted, shivering candidate applies too much pressure or crimps the cap too high up on the explosive compound, the cap will instantly detonate in their hands, causing a catastrophic double amputation of the upper extremities. To manage this extreme risk, the Sapper instructors enforce a zero-tolerance policy for safety violations. If a candidate drops a blasting cap, or if they fail to calculate the correct burn rate for their time fuse, they are instantly dropped from the course. The burn rate of a standard military time fuse is approximately 40 seconds per foot. The candidate must mathematically calculate exactly how many feet of fuse they need to safely sprint away from the blast radius before the massive shockwave destroys their internal organs. There is no margin for error. The explosive does not care that you are tired. The final phase of the course is a grueling, multi-day field training exercise that combines extreme physical attrition with continuous, complex demolition missions. The candidates conduct airborne insertions or helicast into freezing lakes, swim to the shore with their heavy equipment, and immediately begin clearing simulated minefields. They utilize Bangalore torpedoes, heavy explosive-filled steel tubes, to violently blast through concertina wire obstacles. They construct expedient linear shape charges to cut through steel plating, utilizing the Monroe effect to focus the explosive plasma directly into a narrow, armor-piercing blade. The attrition rate at the Sapper leader course remains historically brutal. More than half of the candidates who arrive at Fort Leonard Wood will fail to earn the Sapper tab. The vast majority of these failures are not driven by physical weakness. They are driven by cognitive collapse. The military actively wants to identify the soldiers who can separate their physical suffering from their intellectual responsibilities. The Department of Defense understands that in a near-peer conflict, the ability to maneuver mechanized forces will determine the outcome of the war. That mobility relies entirely on the combat engineer. The millions of dollars spent operating the Sapper leader course and the thousands of pounds of live explosives detonated during training are an incredibly cheap investment compared to the cost of a paralyzed armored division. The Army breaks these men down, starves them, and deprives them of sleep to forge a specific psychological resilience. They are creating a leader who can look at a massive steel bridge while taking enemy fire, completely ignore the chaos, calmly execute a complex algebraic equation, and bring the structure crashing to the ground with absolute terrifying precision. If this gave you a real picture of what it takes to earn the Sapper tab, hit the like button. Drop a comment, did you attend the Sapper leader course? What was the moment the sleep deprivation got to you? Share this with someone who thinks combat engineering is just digging holes. The demolition failure rate will end that conversation immediately.